In today's video, we're going to continue our discussion of translation and look at the second part of translation, specifically how this process actually works. And we've been discussing transcription, translation. We've talked about transcription. We've talked about how that messenger RNA strand is made. We're now looking specifically at translation and how messenger RNA is going to connect with transfer RNAs that carry specific amino acids in order to create a chain of amino acids to create a polypeptide chain. So before we actually get to the steps of how this happens, we need to take a look at and see how that transfer RNA is connected to the amino acid. So I have a nice image here that will help us kind of take a look at this. We have a specific amino acid, and it's going to be connected to a specific transfer RNA molecule. And to do this, some energy, some ATP is required. And so we have a specific a specific enzyme here that's going to fit or have the same shape and molecular composition as in order to match with the transfer RNA. And so this amino acid connects to the enzyme as well as the ATP. And in order to make this occur, two phosphates are lost. And so we go from ATP, adenine triphosphate, to a single phosphate, AMP. The connection of the specific transfer RNA molecule, its shape and its polarity fits specifically with this enzyme. This enzyme is responsible for connecting one specific amino acid with one specific transfer RNA molecule. So this enzyme is only going to do this specific amino acid and this specific transfer RNA molecule. In order to connect the two, this AMP, this molecule that has one phosphate, is going to be released. And so that actually connects the transfer RNA molecule with the amino acid to make a charged TNA molecule. And then that charged TNA molecule with its amino acid is released, and that enzyme can be used again in this process. And so really what's happening is the amino acid is connected first, ATP is used as energy in order to connect that. Two phosphates are lost. The specific transfer RNA molecule is connected to the enzyme, and then by the removal of AMP, we have this charged TNA molecule. And again, really important to reinforce that this enzyme is only able to connect with a specific type of transfer RNA and a specific type of amino acid, and it can only do that one specific type. So here's another image to kind of look through this. The amino acid, again, plus ATP has a specific activating enzyme. We lose two phosphate groups, and so we have amino acid plus the AMP. Specific tRNA comes along, the AMP is released, and we have our charged TNA molecule with amino acid that's connected to a specific tRNA. And so let's look at these steps a little bit more closely written out. Each tRNA activating enzyme recognizes a specific tRNA molecule. So it's just one activating enzyme that's going to be responsible for charging one specific tRNA molecule. The tRNA molecule is composed of double-strand sections and loops, and really the chemical properties and 3D structure of this tRNA allows it to fit specifically with a specific enzyme. The 3' end of the tRNA has a nucleotide sequence of CCA, and this is actually where the amino acid is going to bind to. The tRNA activating enzyme binds specific amino acid to match the tRNA molecule, and this process requires energy in the form of ATP, as we just looked at. And so ATP is driving that force, or driving that connection of transfer RNA and amino acid being put together. So now that we've talked about how that transfer RNA molecule is made and how it's joined with an amino acid, we can talk through actually the process of translation. And I'm going to use this image to kind of walk through the steps as we did in class as well, and then the next couple of images will be typed out lists so that you can see specifically what's happening. As we talked about previously, the ribosome is made up of two different parts, our large subunit and our small subunit, and that's represented by these two shapes here. We also have our messenger RNA strand, which is identified here, and this is our 5' and our 3' end. Now on the ribosome there are three different sites, the A, the P, and the E. And these are three different sites, two of these where specifically transfer RNA molecules are going to bind to. The A site is the first site that a transfer RNA molecule will bind to. And so depending on what the mRNA code, what it calls for, what its codon is, a specific transfer RNA that is the anticodon to the messenger RNA codon is going to match with it. So the ribosome reads that code the codon on the messenger RNA, and it forces or brings in a transfer RNA molecule that has a specific anticodon that matches. After the first one occurs, that transfer RNA molecule gets moved to or bumped to the P site. The P site's the middle site, and in doing so, the large subunit moves forward one codon on the messenger RNA strand and moves our first transfer RNA molecule to the P site. Now, after this continues to happen multiple times, or after the first one, we'll see amino acids, represented right here by these different colored circles. They will actually be bonded by peptide bonds, so we're forming a peptide chain at the P site. So the large subunit moves forward. This large subunit is going to move forward. In this direction, we're moving in the 3' to 5'. The large subunit moves forward. The transfer RNA gets moved to the P site. Try to draw an arrow here. And then the small subunit kind of catches up. And so it's this continual process of moving one codon at a time, and each new codon calls for a different tRNA molecule. And so what we see happen is these amino acids get connected or bonded, and they're kind of pushed out or moved out of the top of the ribosome. And so if you were to see a computer animation or video of this process, you'd see the ribosome, and you can see this growing chain of amino acids that's making our polypeptide chain. The E site, once a transfer RNA molecule has made a bond with the next amino acid, it's released from the transfer RNA molecule. This transfer RNA molecule that's at the P site gets pushed to the E site. It's kind of the third step, and it doesn't bond or doesn't connect with the messenger RNA strand. Only 2 amino acids can be bonded to the messenger RNA strand at any one time, and so this transfer RNA doesn't bond to it. It gets moved to that E site, and then essentially it gets ejected from the ribosome. And so it's released, and that can be reused and recycled again. So it's just released from the ribosome. And so this process continues and continues and continues, essentially until we get to a stop codon on the messenger RNA strand that tells it to stop. There are some promoter molecules that would be present on the beginning of the messenger RNA strand down in this region towards the start codon. For our purposes, you're not required to know the specific promoters and molecules that help to initiate all of this process. That's kind of a general overview, and so now I have some numbered steps that I'll go over to kind of help outline this as well. So our first step, the tRNA containing the matching anticodon to the start codon binds to the P site on the small subunit of the ribosome. Number 2, the small ribosome subunit binds to the 5' end of the messenger RNA and moves in a 5' to 3' direction. So just like transcription, we're moving from a 5' to a 3' direction. The large subunit binds to the small subunit. The tRNA with the matching anticodon to the next mRNA codon binds to the A site. Amino acids on the 2 tRNA molecules form peptide bonds, and the large subunit moves forward over the small subunit. So that steps 1 through 5 is really kind of the first chunk. And so then that large subunit moves, and in step 7, the small subunit rejoins the large subunit, moving towards that 3' end on the messenger RNA. The first tRNA is moved to the E site to be released, as we discussed, and then another tRNA molecule is going to be brought in at the A site, and that second tRNA is going to be moved to the P site. This process essentially continues and continues, and it's building a long polypeptide chain, which is a protein. And it continues until the ribosome reaches the stop codon on the messenger RNA. And really, you can kind of think of this as an off switch. It's basically telling or indicating that the process should be completed, and no more amino acids should be connected together. And so we get a polypeptide chain is formed. It's going to be folded into its appropriate shape and then transferred to wherever that specific protein is needed in the cell. And so really, this is the process of how we're taking DNA, making messenger RNA from that, and then specifically making a protein based off of that messenger RNA code. So I kind of like to think of the DNA as kind of the showmaster or the puppeteer, kind of in the background, even though it's not out in the cytoplasm or on the endoplasmic reticulum controlling all of this. The code or the information that's copied from DNA into RNA is what's driving all of this and making sure that the specific order of amino acids that are connected is followed correctly. And so that's translation.